Hello. Um, uh, Tonight, it is night for me. I'm going to talk about debouncing and throttling. Um, so, uh, there are two methods of improving performance for an application. Um, a lot of processes can be can take up resources, can lead to bugginess, can crash an application because so much is being processed that the app can't keep up with it, or the process is a network call and the way one wants the programming to work, there's tons of network calls or these network process calls um, that happen, and that just uses up too much bandwidth and isn't necessary. So these types of matters. And To get into it, uh, with with I'll get a little thicker pen here. With debouncing, um, there is a delaying of an associated process um, until whatever is causing the process to be called after a delay um, stops happening. So usually this is a browser event or an input. Let's say e.g. typing. So a person may type a F here, and there's an event associated with this, and of course an event handler for it. And the event handler specifies what the associated process is. In our case, let's say that is a syncing to a server and persisting some app data. So at this point, there's a waiting um, of the process, uh, of calling the process for a specified amount of time. And if there's another event before this scheduled calling of the process, then uh, that scheduled call is canceled and the loop is set over again. So in our case, let's say there's an O typed here. Well, then that's canceled, and then we set it into the future for however long the debounce time is. Um, and then once you get here, you know, then we do the associated call. In our example, the network call to persist the app data. So I am going to show this. I'm going to code up the debounce function, show some code, and then run it in the console. And here I go. Um, of course, it's always nice to do the core JavaScript. That's what I'm doing here. I may be a bit shaky and things may be off, but we'll get through the errors easily, I hope. So, document on load. What I want to do is show the clienting of debouncing first. So let's say let input query selector input. Now input add event listener. On key down, let's say. Debounce. We'll have the event data passed, and the amount of time we want to delay the delay time for handling the associated event. 350 milliseconds here. And let's just have it console log event. So, of course, if you're not familiar with debouncing, but you are familiar with event listening, you can deduce that debounce returns a function because that is how event listeners work. They are passed functions, which are called when an event occurs, or more specifically, when the event handler is called when its turn in the event queue comes up. So now let's get to the actual debounce function. Function debounce, the fn, the actual function that is getting debounced, and our delay time. And this is code that I came across on the internet, and I already had a practice run on my notepad of writing it out, so I basically know what to do here, and we'll dissect it after I type it out. So here we go. I'm not cheating though. For my own practice, I am trying to do it from memory, which is always good. So we return a function because that's what the event listener wants to ingest up here, and I probably should have explained a bit more of the mechanics before writing the function, but I guess I will after. But I gotta kind of talk it through to myself first. So the function is going to potentially clear any previous events that were debounced, because we only want one actual associated process to be called. So we're going to do clear timeout. And then set timeout. And so this function here is what is called by the JavaScript environment when the event handler is called when it's in the front of the event queue, and we're going to call our actual associated process, which is console log event, via the timeout, but we're going to want to save the arguments and this, what this is, from the function called by the JavaScript environment. So we're going to do that by doing this. And then use a handy dandy function that I don't use that much, but I see in libraries and I know how it works and is important for my future and current growth. So it is the apply function. So it is called off a function, and you apply what the this keyword is for the function. And that in our case will be context, and we'll pass in args, which was saved in the original call of the function fired from this event, the key down happening. So, and that our arguments, of course, is an implicit object in function calls that is the arguments list. I'm following how the examples I found online do it. It's a clever way of getting all the arguments that would be in this section right here, but just accessing them via the arguments implicit object. And apply basically works by applying the function, applying what the this keyword is in the first parameter and the rest of the arguments as an array in the second parameter. And that is that. So I'm trying to see here if I'm missing anything. I gotta look at my notes on how to do it now, see if I did it right. I'm pretty sure that I did. Cool. So I think I can talk through what's going on here. Or, maybe I'll do half and half between the editor and the whiteboard. That'll be good. Cool. Okay, so let's think in terms of a key down event. Well, we have our associated event, which is returned by this debounce function. Our associated event handler, which is this guy, right? So, on the key down of our input here, what happens is the event goes into the event queue. So let's just, I don't know, say it goes into the queue. Oh, what the hell is going on? Oh my god. That was weird. Okay. So the event goes into the event queue, makes its way to the front, finally gets processed, and we have our associated event handler execute, which is this function here. So the first time through, clear ID is basically undefined. So we clear timeout on undefined. That doesn't do anything, which is fine. We set timeout for whatever the delay is, which is in our case 350 milliseconds. So we have a timer event via set timeout that will do function apply, which is our console log in 350 milliseconds. So there is then this timer in the not in the JavaScript environment, but in the browser environment that is timing, and so we can just say it like here, timer. It's counting down, right? It's trying to get down to being no more time left, and oh shucks. Oh, I'm seeing I missed one part. Okay, cool. That's good. We can do that now. So we do clear ID equals set timeout. Yeah. Okay. So the first time through, we reset clear ID to some ID. Let's say it's 123. And our timer is starting, right? And let's say another key down event occurs, like a second one. Well, it's going to go into the queue, do the same thing as before, and execute this function, which is the event handler. And we're going to clear timeout. Clear timeout turns off the timer that's occurring. So it stops this. Right? And it stops the previous timeout and makes its own one here and resets the clear ID. And does a new timer. It starts ticking down. Gets to 0, let's say, so the user hasn't keyed down at all. And then the fn apply, which I explained how it works earlier, is called, which is this function here, the one is passed into the debounce console log event, and it will be the last event, the last key down event that occurred. Now, real world, a good example of this would be, okay, the user typed in some app data. We don't want to use up network bandwidth or our server's compute power, so we're only going to persist the data once the user's done typing. So now that I've explained how this works, let's see it in action. M. Oh. Doesn't seem to want to log. Darn. So if I troubleshoot here, let's see what's going on. Huh. I might be able to salvage this presentation. What's going on? Document on load, maybe? Maybe window? X input, okay. Okay, so I'm debugging here. Key down. Key down. Okay. There we go. Alright. And I should probably give myself a little bit more time to show it in action. Let's say 750, so 3/4 of a second. I'll type out my name, and at the end we should only see console log only once. Cool. Alright, so now getting on to throttling. So throttling is a little bit different in that based off these events and associated processes, there will be the associated process will execute only will execute a given or specified frequency. It won't be a higher frequency than specified. I didn't verbalize that too well, but to say it more simply, throttling will keep the time between associated processes for events to a minimum time. Is that right? So essentially it is, let me give one more go at explaining it. I'm trying to find the right way to put it and say it succinctly. throttling will take a series of events and have uh, the time between associated process calls for the events um, be above a like a minimum threshold. Okay, that works fine. Um, so I'm going to just give some pseudocode for throttling and then introduce its usage. Um, or, I could talk about a good real world example for throttling first. So, throttling is good for infinite scrollers. I recently was researching infinite scrollers, kind of like Instagram or Facebook, and the the idea is the app creators want to have a very performant experience with these infinite scrollers, and the on scroll event for a browser is gonna fire a lot, right? So it needs to be throttled so that the associated infinite scroller processing only happens every so often, and and that potentially heavy process is throttled. And um, I actually found an example of this in an infinite scroller library, which I'll talk about after I show my quick write-up of code. Um, so let me do the write-up really quick. I'm at 27.5 minutes into this presentation. Almost done. Okay, let me try to remember here. So we're going to want to have throttle time, and a flag, which I will call isBypass. All right, and I shall do on scroll. Let's make sure, just for correctness, that I follow the right wordage for the event. Kind of like spell checking. Add event listener on scroll. And this is going to fire a bunch, right? With scrolling, a user scrolling and they're, on their mouse. Well, the general idea is to set a timeout for the call, the associated process call, and only have this timeout occur if we're not in a state of a previous event having the process being called. And this is facilitated by the isBypass flag. So here is the code. If we're not in a state of bypassing events, then set timeout. We'll do it for the throttle time. Console.log do work and is bypass equals false. So this code is gating events. So one event kind of gets through the gate, which is bypass is false. That one event then sets a timeout where at the end of it having control of the gate, it does the work and then reopens the gate by setting isBypass to false. And you can see it closes the gate at the beginning of the set timeout, at the beginning of the whole system for one event that has access to an open gate by isBypass equals true. And my very favorite library code recently for this infinite scroller has this in action, and let me introduce the library first. Airbnb did an infinity scroller library which has a creative license, so that's really cool. They made this library available to the population for open source usage. And I don't want to go through the extra time of showing the scroller, but it was very performant. And I digress a little bit, but this will be a little bit of foreshadowing. I will have a presentation soon on infinite scrollers and also browser performance. Really cool stuff that I didn't know that much about and then got into and am now learning. Cool. So last but not least, before ending the presentation, let's look at the throttler code, the throttle code in the Infinity.js script. So they have this DOM event object, and their flag, like their isBypass, is scroll is scheduled, or scroll scheduled. And DOM event is this immediately invoked function expression we see here. So it has all of these functions which are private functions, and it's returning this object with an attach function, right? Window on scroll handler. Also, this pattern, which I just kind of displayed here, is the revealing module pattern, which is a great way to do encapsulation or kind of security with JavaScript, and to get into the throttling aspect, this DOM event object, which is this guy, can attach list views, which are infinite scroller related type, and essentially the first list view that comes through here and attaches enables the scroll handler binding to the scroll event on the window, and scroll handler is up here. Now we can match up our code, and I can kind of do some sanity checking here. If scroll scheduled is false, my is bypass is false too at the start. If we're not scroll scheduled or is bypassed, then set timeout for scroll all function, which is their process, their heavy work that they've got to do down here. So if the scroll isn't scheduled, set the timeout. You can see how the code is similar. Scroll all. So scroll all. So I don't have a name for this function, but this is my scroll all, and the scroll all is here, right? So scroll scheduled, which is the flag, is being set to false at the end of the timeout. My flag, which is this bypass, is doing the same thing. And at the beginning of the passing through of the function that has an open gate, if you will, we're doing is bypass true, scroll scheduled true, so everything is good. This should work, and I kind of did a gut check against this real library's throttling here. Yeah. So in conclusion, debouncing is good for making the software system more efficient, and a good real-world example of this, as I went over in the first half of this presentation, is only persisting data that is in an app and probably is a user typing at the end of the user typing, which is assisted by this debounce function. And the other theme tonight is throttling, and throttling by definition is having associated process for a series of events have a minimum threshold between the associated processing. There's probably a way better way of me putting that, but I am going to have to go with what I found to work in this prez. So, and finally, the good example, real-world example of this is infinite scrollers. Infinite scrollers can make very good use of throttling because the associated processing for scrolling, for updating infinite scrollers when a scroll occurs, is a heavy process, and scroll events are numerous when a user is scrolling. So use throttling to make the code not do extra processing, and I suspect in the case of infinite scrolling, not crash the component in the application, because if you wouldn't have throttling, you could get a big stack of of the scrolling code stacking up in the queue because previous processing can't finish. So throttling solves all that. All right, that's it for tonight. Thanks for listening. If anyone is out there, one last thing. Me presenting is a very good practice for me. I encourage people, fellow developers, to do the same. It's a great learning tool. That's primarily why I do it. And if this can be helpful, to listeners and viewers as a side effect of my own process here, then that's good too. All right. Have a good one. Bye.